the description, a couple of examples. Good. For units, it has an extensive number of units. If I click over here, let's say, and click on this funnel shape icon, I get this entry form. But first I have dimensions and properties, and it includes a number of physical quantities like acceleration, area, capacitance, as electric capacitance. As you go clicking in here, you start getting in here the number of units available and what the units are, and how to type them. You know, like Faraday can be typed at quote FD, millicoulomb quote MC, and so on. And then you can see here the amount of information that you have. There's a couple of interesting things in here, like the constants. So if you go to the P, physical constants, these are specific values, and you have like the Avogadro's number, Boltzmann constant, and so on. And so I have an entry point right here and say I want to get Planck constant, as I insert, and it gives me H, and I say equal, and it says H is equal to 6.6261 times 10 to the minus 34 seconds times joule. Why seconds times joule? Because by default you're going to get results in the units of the international system. The units of the international system, the fundamental units for that system are these: meter, second, kilogram, ampere, mole for amount of substance, the Kelvin for temperature, and the candela for luminous intensity. And so you're going to get this kind of results in most cases. And here's a listing of all the dimensions available. And I mentioned the quantities, the physical quantities, the physical constants. I'm going to go down here and also tell you about some units, the so-called dimensionless units. These are units that result from the ratio of two equal quantities, like degree for angles, something per mile, parts per million that are using concentration. The radian is a dimensionless quantity, revolution, everything that's angular is dimensionless. So be careful with those. Now, the international system uses a number of prefixes to give you multiples of a certain unit. For example, the kilo means 1,000, mega is a million, giga is 10 million, 100 million, I'm sorry, 1,000 million, a billion in English, and so on. 0.10 is deci, 0.100 is centi, 1 milli is 1,000, and then you have the micro, nano. Of all those prefixes, the only one that uses Greek character is the micro, and you know how to type mu. It's M, Control G. And you got to be careful though, because not all those units are defined in the collection of units. For example, the megagram is 1,000 kilograms. But I want to try a gigagram and I don't get anything. I just get GG. That means it's not defined, but the microgram is defined in terms of the kilogram. However, you can define your own units, and you say, you know, like gigagram, GG is going to be 10 to the 9 grams. And after you define it there, then it is here. But in order to use units, you need to put a quote before the name of the unit. The simplest way to introduce units is by using the units in the box. For example, a force. Let's say F equals 12.3, and then I go to my units, look for force, and let's say I use Newton. Newton is the basic unit of the international system for forces. And what you notice here is that the N has a blue coloring. That's the same idea here, or the same idea here, and so on, because SMath Studio that way distinguishes what is a variable or a name from units by giving you blue in the units. And so there is a lot of information regarding the use of the kilogram force and the pound force. That's a little bit of a headache, because in the past there used to be something they call the kilogram force. So if you want to know what the kilogram force is, you type quote kgf equals, and that's 9.8 Newton. That's just the weight of 1 kilogram. And then there's a kilogram mass, but actually if you do quote kgm, is actually not defined. The kilogram mass has become just the kilogram, and the kilogram is well known. When you type quote kg, it's going to give you 1 kg because that's the basic unit. But there is something called the pound mass, quote lbm, and it's 0.4336 of a kilogram. The pound mass should not exist anymore. The pound has been defined as a unit of force. If you type quote lb, which is the unit of force, it's actually the pound mass, and that is incorrect. But that's the way it survived in SMath Studio. If you type lbf, that's the pound force, it gives you 4.42 newtons. So that's the actual pound that you want to use in your calculations. Now, suppose that you have a calculation that involves units of the English system. You have a mass of 8.9 quote SLUG slug, that's the unit of mass in the English system, and an acceleration of 2.3 quote IN, that's inch, divided by quote second squared. Those are units of the English system, which still persists. And so suppose that we calculate force equal lowercase mass times A. The result comes in Newton, but I don't want Newton, I want pound force. So I go and say, click on the right hand side, get to this placeholder, put quote, and put LBF. That's 1.78 pound force. And that's how you can change your result from any value to another value. For example, if you type F equal, I'll give you back your force in newtons. Click on the placeholder and type quote DYN. That's a dyne. A dyne is an all metric unit of force, which is very small, and so it tells you that that force that originally we found to be 7.58 newton is 7.58 times 10 to the 5 dynes. That's because 1 newton is 10 to the 5 dynes. And so you can change the units by clicking on that placeholder in any result and replacing that result. For example, this is second times joule, right? A joule is a unit of work. That's a Newton times meter. So I could type here quote and say, okay, I'm going to do quote Newton times quote meter spacebar divided by quote second. And so what I get is now second squared, because I'm putting this second. If I take this second out, it gives me second times Newton times meter, that's joule. And so you can change the units as long as you know the equivalent units in there. One more thing I wanted to mention is information. Information is in bytes and bits. A bit, if you could quote BIT, is 1 bit. That's the basic unit. A byte is quote BYTE equal 8 bits. But suppose that you want to do 1 kilobyte. So you type quote KB. That should be kilobyte. But it's actually giving me 8,000 bits. So if I have 1 byte is 8 bits and 1 kilobyte is 1,000 bytes, just give me 8,000 bits. But in reality, a kilobyte is not really 8,000 bits. It's 10 to the, it's actually 8 to the 12. No, sorry, not 8 to the 12. 2 to the 12. To the 10, sorry, 2 to the 10. 1024, which is close to 1,000, that's why they call it a kilobyte. In order to resolve the problem, in SMath Studio they use quote KIB, and this 8, and then let's type here byte, and 24 bytes. So just be careful with that information. and enjoy using units. There's a lot of information to be used in there, and I hope you find this very useful. With that, I conclude my presentation on the use of the functions and units icons in the top panel in SMath Studio.